Hello all, we are learning the Simulink library blocks. Okay, so in that Simulink library block, we are learning the ports and subsystem. In ports and subsystem, we have finished the various types of subsystem and conditionally executed blocks as well. Now there is one more conditionally executed block is if action subsystem. Okay, so we will learn about this is action control subsystem and merge block as well, which is present in here only itself. Okay, so let's get started with if action subsystem. So what does the if action subsystem will do? The if action subsystem block is a subsystem block for pre-configured as a starting point for creating a system whose execution is controlled by an if block. Which block? If block. So we will learn about the if block also. What the if block, like if else condition should be passed through the if block and all these things we will see. We will do one example as well now. The if block evaluate a logical expression, and then depending on the result of the evaluation, output of an action signal, execution of the subsystem is controlled by an action put block placed inside the subsystem. So here, inside the subsystem, you can see in the image, if action subsystem inside it, this action port block will be placed here. And it's taking a command from the if action port. Here you can see if your u1 is greater than 0, so that action port should be taken that in that way it will work. Okay. So Simulink ignores the priority set of an if action subsystem block instead of the set of priority on the if block that initiates execution of the subsystem. So it will go the priorities with the first else and then else condition. In that way it will work. So the merge Simulink for if action subsystem block, for an example you can see here, the I have connected merge block here with the three outputs here of if action subsystem. So if block is selected, so what is a merge block? We will study first that. So here you can see the merge block. Merge block combines inputs into a single output. Whatever number of the input, it should be converted into a single output. Here you can see I'll be having a two enable subsystem. Any one subsystem should be activated at a one time and it should be giving us a output. So that's the coming output should be displayed in a output, whatever which subsystem will be active, and that output should be displayed here. So on that principle, merge block will be work. So the output value at any time is equal to the most recently computed output of its driving block. Specify the number of inputs by setting the number of inputs, the parameter. From our merge block, we can set how many number of inputs should we want to connect here, that we can change from here by double clicking into a setting. Use a merge block to interlevel interleave input signals that update at different times into a combined signal in which the interleaved values retain their separate identities and times. To combine signals that update at the same time into an array or matrix signal, use a concurrent block. What are the guidelines to use this merge block is always use a conditionally executed subsystem to drive merge block without any intervening blocks. Okay, so at the merge block, input should be connected to the conditionally executed subsystem. That all the conditionally executed subsystems are atomic subsystems as well. That important point you have to know about, that all the conditionally executed subsystems are the all the conditional executed subsystems are atomic subsystems. Okay, we already studied about that enable, trigger enable, function call. These are also enable conditionally executed subsystem, and if action subsystem is also conditionally executed subsystem. Ensure that the most one of the driving condition executed subsystem execute at any time step. Ensure that all input signals have a same sample time. So do not branch a signal that is input to the merge block. So do not log a signal that is input to the merge block. Do not specify a block execution priority of a merge block for like information like specific, if you want to see the execution order and all this thing that we do not need to do. For all conditionally executed subsystem output block that derive merge block, set of output when disabled to held only. Okay, so if like all having the same condition, if enable is having reset, so both subsystems should be on a reset. If it's having disable, then both should be having a disable. In that way, it is hard. Okay. So the merge block supports a merging of a signal with different tasks at a root of the output. For each input of a merge block, the topmost non-virtual source must be conditionally executed subsystem, not including like iterate while iterate like iterator subsystem. The next in that we can see how you can see in this diagram how merge block is working. Here I have connected with a NOT gate. If my input is 1, then it will directly work and this will become a 0. If my input is 0, then this NOT will become a 1 and this will work, this will not work. In that way, this merge block will take inputs and give the appropriate output. Okay, so now in if action subsystem, here you can see I have used the merge block here. Here it is taking a 3 inputs and any one input should be active at a time. Any one subsystem should be giving us an output at a time. So if block selects the execution of if action subsystem block from a set of subsystem, regardless of which subsystem the if blocks selects that we can create one output signal with a merge block. Okay, all blocks in an if action subsystem block must execute at the same rate as the driving if block. To satisfy these requirements, set the sample time parameter for each block to either inherit like -1 or a same value as the if block sample time. Like all will be having a same sample time and it should be work on that on same sample time. So let's get start learn about the example. So here at the top level, you can see I will be having input as an angle and display I'll be having what angle we want to see in that way. So what I implemented with this same logic I am here. So you can see if my output, when I want to see output as an angle, whatever my input, that same output I want to see, then my angle range, what is angle, this angle, what is I am giving in a degree, that angle range is pi by 2 to 3 pi by 2. That means 90 degree to 270 degree. If I am giving an angle in between 90 degree to 270 degree, then only whatever the output, that whatever the input angle should be displayed at the output. But okay, if my output is equal to 0, when my input is less than 90 degree and it's greater than 270 degree, and at time my input will be 0. So here you can see in this logic, I have taken an input here, and you can see the from and go to block we have studied previously how and how here I have used for if action subsystem. Okay, so from here I am taking the input and I am doing some operation. I will show you here. Initially, what I did, this subsystem is converting degree, TGRW degree, to radian. Okay, this subsystem is converging the whatever given input angle degree into a radian. How it will be convert? So we using this formula we can convert like whatever input like angle multiply by pi divided by 180. In that way, we will get a radian output here. And whatever we are getting the radian output, you can see here I am comparing. First I'll be having if condition, second else if condition, third is else condition, and this is a if block. This is a if block. If you want to take this if block, you can just come here, search if. You will get here in Simulink ports and subsystem, you will get this if block. You will get this if block. And how we can configure this if block, you can see here the if block, if expression, run an action subsystem connected to the first output. Okay, else if expression, run an action to the rather an action subsystem that connected to the second output. Else that rather an action should be connected to the last output. Whatever it is connected, it will be having given connection and it will run an event. So the number of else if ports in a block is equal to the number of comma separated else if expressions entered in a dialog box. So we have like else if expression can be in a MATLAB operator using this greater than, less than, equal to, or like not equal to. There are so many operations, and the inputs ports name should be U1, U2, U3, etc. We will not able to change this input port names. Okay, fine. So here you can see I'll be having one input, number of input. So I'll be having two if else condition. If I am changing to two input, then you can see again here in this subsystem I'll be getting two inputs where I can write a logic of U1 is greater than U2 and U2 is greater than U3. In that way also can I write a logic. So but here what I have did now, use only if else condition because I want only one input which is coming in a radian. I have converted here in a radian. So here you can see what I did here. I did here if action subsystem. Okay, where u1 is greater than 4.7124. Why this is 4.7124? I'll show you here. Okay, I'll take this as a copy here. Control this logic. I'm just making for your reference in front of you and delete. Oh, Control Z. Okay, and I delete this. I'll delete this as well and take a display here. Okay, I'll connect a display here and I'll take here constant one more. I'll connect here and I'll give the value to 70. And now, if I am running this simulation, you can see I am getting a value of 4.2712. 4.2712. If I'm making this display into the large, okay, apply and okay. Now you can see is a 4.2 or 4.172388. That should be, I can consider a 4.17234 as well. Okay. So what is this? What is that if I have taken there? So if you are able to see here, what I want to do, according to condition, my angle should be like less than 270 degree or like greater than 90 degree. Then only I will be passing your output. So here I have checked that condition. Here you can see I have two and conditions here where the angle should be greater than 270 degree. So that greater than 270 degree means that u1 should be greater than this 4.7124. Okay, and that second thing is like where I'll be checking my u1 should be less than 90 degree. So for 90 degree, what value I will get in a radian? You can see now what I have taken the values there in a radian. So with some basic example, you can see now here 1.570. So here I have taken that same value that u1 should be less than this. Or else means if value lies in between these. If my value lies in between these, then I want to pass exact output here. I want to pass exact output. So now you can see what I did here to do this, pass these conditions. I am taking an input directly, that action here. If is my angle is greater than 270 degree, then I am directly multiplying with 0 and giving a output as a 0. Same for this also, if my angle is like less than that 90 degree, then multiplying by 0 to the angle and giving as output. But if my angle is lying in between like 0 or like line 90 degree to 270 degree, at that time I am taking the same output, same angle of output. And this merge block I have changed here from the property which I have already discussed. Number of inputs, how many number of input we can change it from here. I have taken a 3 inputs and looking at the output part. Okay, so this is all about that condition mathematical expression, and I have implemented this mathematical expression using this if action block. Now we will see how it is working. Okay, so at the top level you can see I have implemented that all thing inside one subsystem now. If I am giving value, okay, which is less than 90, I can give 1, 2, 3, anything. 23 I have given here, which is less than 90. Okay. If I am simulating model now, what output I will be expecting? It's 0. But if my input angle value is 90 degree, so what output should I accept now? It's a 0 here, but I want greater than 90 here. So what I will do here, like 91 I will be taking here and apply, and okay. Now we can see what output we will get. We'll get exactly output here. So that condition is greater than equal, like greater than, in my output should be in between 90 to 270. That is satisfying. If I am taking suppose 200, so does it satisfy? Yes, really it will satisfy because it's performing our range equation here, what it is here, written here. Okay, inside it. Okay, fine. So if I am giving the value, okay, which is greater than 270, like 274, if I'm giving. So what will happen? What will happen? Now here you can see if I'm giving it is greater than 270, so I'll be getting output as an 0. So my all these conditions should be satisfied. If my output should be here in between this range, or my that angle output should be my exact angle. If my input is 90 to 270, or if my input is less than 90 or greater than 270, then output should be 0. That all conditions should be satisfied here. So in this session, we have learned about the if action subsystem, if action block, if action subsystem, and merge block as well. And one more basic logic we have learned about that, how we can convert a degree to the radian and radian to the degree. So this is pi divided by 180. This constant, if you want to know, in Matlab we can write a pi instead to using a pi value. Okay, in Matlab we can write a pi to using a pi value. Okay, if I'm doing nothing here, if you want to see here, I'll take one constant in front of you. I'll show you. I'll change this value to the pi. Okay, so it will take a value of a pi. I'll connect a display here, and I'll show you that pi is predefined mathematical function variable. So you can see here that pi indicates 3.142, which is the pi value. Everyone know about the pi. Okay, so pi is like 90 degree. If you say some degree in that degree in radian, pi is 3.14142. That's it. So this is an example where which have studied about this equation, like mathematical expression which we have passed using the if block, if action subsystem, and merge block. So that's all about this. We will meet in some next session with some new topic. Thank you.